Okay. We start with toolkit exponential function. I mentioned that point is 0, 1. Why is it 0.01? It's because when you do this subdivision of the exponential function, now I haven't drawn it very accurately, but we cut the rectangle in half. We cut the lower rectangle in half. We cut the lower rectangle in half. We cut the lower rectangle in half. Up here, y equals 4, because this is a 4 by 4 square. Y-axis is here. Because the red dot is down here. It's the red dot. And then if you go twice as close to the lower edge, from y equals 4, you get y equals 2. Twice as close as that gives you y equals 1. Twice as close as that gives you y equals 1/2. And twice as close as that gives you y equals 1/4. And these points are on those lines. And you construct a graph and move over one up, one over one up, one over one up, one over one up one. So that the x coordinate here is 1. Here it's x equals 2. Here's x equals -1. Here it's x equals -2. Where the x equals -2 line crosses the y equals 1/4 line is where you start. The coordinates of that point are -2 1/4. Where the next line, which is the x equals -1 line, crosses the y equals 1/2 line. One is -1 1/2. This point occurs where the x equals 0 line crosses the y equals 1 line. So that's why the coordinates of this point are 0, 1. And why is this 1? Because if you cut 4 in half, you get 2. If you cut that in half, you get 1, etc. Okay? Make sure you understand every detail of that. And then for y equals 2, you get 1, 2. And for y equals 4, you get 2, 4. So just make those a little more prominent. Emphasizing circling them in blue. Now the average slope between x equals 0 and x equals 2. Here's the x equals 0 point, and here's the x equals 2 point. Okay. X equals 0 on this vertical line, and that's the point that's on this vertical line. Make sure you understand these vertical and horizontal lines and why they're labeled the way they are. We've talked about it repeatedly. If you don't understand it, you can access the MDE 61 videos. They're right there on the assignments page. Okay, just click on it. And you can see the video we did today, which goes into a lot of detail on the meanings of these lines and slope, because that's really what we talked about, and rate of change. Okay, I'm going to talk a little bit more about rate of change than we did in that class. And I'm talking about what we did with slope very quickly. If you don't understand any of it, look at that video. Okay. Directions for accessing the assignments page or Canvas. If you try to access it through Canvas, can't, send me an email telling me what you did in Canvas and why it didn't appear to work, and I'll send you the link. But I don't have time to send a lot of links. Okay, especially today because got a big meeting this afternoon and got to run to the hospital. And stuff like that, okay? So please don't ask me if you haven't really tried to access it through that. And I've also sent an email with the link to the assignments page. I also sent a link that takes you directly to the assignments for this course. That's not the assignments page, that's the assignments page for this course. You should have both links in your email. I think they're both accessible through Canvas. If there's a link in Canvas and you click on it and it doesn't work, tell me that. Okay. Okay. Do that much. And then I can almost certainly, it'll be a priority for me to answer emails of that nature tonight and tomorrow. Okay, tomorrow I have more time. Okay. Between here and here. Run is 2. And the rise is 3. Right? Why is the rise 3? Because you go from y equals 1 line up to the y equals 4 line. From 1 to 4 is plus 3. Okay. Why is the run 2? You go from the x equals 0 line, which is the y-axis, to the x equals 2 line, and that's a run of 2. From 0 to 2, you've got to run 2 units. Okay. Remember to do arrows here and do this construction. Do the details of this construction. You did the details of the construction of all 3 of these functions, and you did it quite well in the first week and a half of class. Okay. If you can do that, you can do the details of this. Okay. Make sure you do. Very important. Okay. So the run is 2, the rise is 3. So the slope is 3/2. I put that in a box next to the line that slopes between these 2 points to indicate that that's not a distance, it's a slope. Okay. If I put a box around it, I know that that means slope. Use that convention to make things clear to yourself and do a nice, neat, detailed picture of this and make sure you understand every detail of what you're doing. Okay. It's right here. All you got to do is flip to, 8.5 minutes into the video or whatever it is right now. And there's a picture. If you understand most of that, and I think you understand the construction of these graphs, okay, then the rest of it ought to be pretty obvious if you think hard about it. And it might be obvious to you already. But don't let it go by without being able to do this little picture. It's really fundamental. Okay, well, that's the average slope between x equals 2 and x equals 3. Okay. So we could write that calculation. I'll just say boy. I think by now I'd know to think before I write down numbers. No, that's too easy. Okay. All right. And it's not 2, it's 2, 4. And the rise is 4 minus 1 over 2 minus 0, which is 3 over 2. Oh, okay. I got carried away and did the whole slope. The rise is 4 minus 1, the run is 2 minus 0. You get 3/2. You got a formula that tells you that y2 minus y1 over x2 minus x1. But I want to see it on a graph if I ask for it. Okay. And I recommend that you always do the graph, at least in your head, that you should do the graph at least a dozen times so it stays in your head. Okay. It doesn't take long to do this. You draw this whole picture and label everything in about 2 minutes. So if you do that a dozen times, you're taking 20 minutes to lock in something that really shows you what graphs mean, or at least puts you in a position to much better understand what a graph means and what it's telling you, because this gets us right to the idea of a rate of change. Okay. So I defined average rate of change previously as changing that over changing this. Okay. And I think we talked about, well, if that is y and this is x, then it's change in y divided by change in x, right? Or if it's, I think I addressed this in the video that I did Sunday. I think things kind of blur, especially with these videos. Okay, pretty sure that was Sunday. Change in output over change in input. Okay, the rate of change of output with respect to input. Well, if it's changing that over changing this, change in output divided by change in input. We made that connection pretty explicitly in class last time, and I kind of think maybe I repeated it on Sunday because in class I might not have used the terms output and input, which are open math use quite a bit. Okay, worth looking at. It's the most fundamental idea in calculus. And again, we're trying to prepare you for calculus. I want you to understand rate of change because you won't understand calculus unless you understand rate of change. And I see people that have been through calculus, even engineering calculus courses, that still don't understand rate of change. Your life is much easier if you do. Okay. Yeah, rate of change is extremely important on its own. All right. I did a really pretty good example in the MDE 61 class of right. I better know where it is or it'll hurt me. Look. The example I'm going to use is all goes down this road. Okay. Now, 1001, 1002. It went a quarter of this distance in 2 seconds. In 1 second. In 2 seconds, it went the whole distance. Okay. 1/4. -2 to 2. Okay. That's a 2 second interval. That's a 3/4. Never mind. It doesn't relate to the exponential function. It relates to the squaring function. And I forgot what function I was talking about. Okay, we use a different example here, but there's an example I did there that relates all this to the squaring function. And what we can say is the rate at which it was moving down the incline kept increasing, didn't it? It went further in the second than it did in the first. All right. Well, by analogy, we see things going further every second, but because how far they go is the rise. Well, we'll make sense of that. Okay, so if make sure I'm still on board. It's good. Let's say Y is the mass of a rapidly growing mole in grams. And X is the time in hours. Okay. Now, what is the meaning of the 0.01? Let's think about it for a minute. Okay, so 0.1 means what? What does a 1 mean? Then they got the answer. I go, well, that's Y. And then I said, well, what's that? Well, that's the mass of the mole So what's one mean? It means you have 1 gram of mold. Okay. X is your time in hours. Often we'll use T for time, but we're going to use X just to avoid confusion with a different variable. X is your time in hours. So what's the X value of this point? Well, it's 0. Okay, that means then this point means at 0 hours, we have 1 gram of mold. Now, as I said, mold's been growing for at least a while, okay? And at this point, that's where we start our clock. Okay, so our clock starts at 0 here. Okay, 0, 1 means 1 gram of mold with time is 0 hours. Okay, so now, and write this down in your paper. Let's see if you get this. Maybe less than a minute to write down what this means. Going to take that many words, you can write it quickly. I'll start, but I'm not going to put pressure jacks. Okay, I'll come back. Okay. To interpret that, all you got to do is look back at what I just wrote about that, right? It'll be very similar. Yep. The middle right here. You pretty much had it. I looked before you had your last couple of words. So I really had to make sure there wasn't a laugh the second one. I was like, hey, people were better on this. Okay. Okay. Everybody either has it or they were busy copying down what I had on the board and hadn't gotten to it, but would have had it. Okay. Okay. So that's good. Okay. That's the pattern. If you have that pattern and can apply it to different situations, some of you walked in before I was done with the last class. Of course, the last class ran over and you're welcome to come in anyway. Some of you saw me doing something about an investment that goes from $3 million up to $7 million in 11 years, okay, or whatever. Same thing, exponential model. You just interpret the points in the graph. Y is your money, and T is your years. Okay, I didn't think I said hours. I thought I said years. Maybe I said hours. Anyhow, 2-4 means four grams of mold when active 2 hours. Okay, and the time is 2 hours. I'll say when the time is well. Try to do that without using X and Y. Okay. So Well, the rise between 2 points in the graph, that'd be this point and this point, is 4 minus 1, right? What's 4 mean? And what's 1 mean? So what I'd like you to write out is 4 what minus 1 what? Okay, so means what? It means, I'll just use G to abbreviate grams. Of course, if I subtract 1 gram of mold from 4 grams of mold, I've got how many grams of mold? And that's the change in the amount of mold, okay? Now, 3 grams of mold occurs at about this point of the graph. That occurs at about T equals 1.7 or something like that. But that's not what the question was, okay? Anyhow, this equals and this is the change in Y. And remember, the average rate of change of that with respect to this is change in that divided by change in this. So we've got a numerator for our average rate of change. Okay. All right. Well, it's not going to surprise you. Everybody did quite well with that. So that's very encouraging. Let me see if the camera's picking up everything. I'm picking up the lowest line. Not picking up the lowest 3 lines than it was earlier. Okay. So anyhow, again, 4 grams of mold minus 1 gram of mold is 3 grams of mold. That's a change in Y. And as I said, that's the numerator of your average rate of change. Okay. Now, probably should. Okay, then. The 2 minus 0, using the points 0, 1, and 2, 4, you got 2 minus 0. That's the change in X, right? And that means and this is the change in X. Okay, so you're changing Y, we have change in X. So calculation of slope means now we'll understand that we're talking about molds. It's 4 grams minus 1 gram, okay? Because we don't have to keep writing that moldy thing, okay? Now, if I do 4 grams minus 1 gram, I get 3 grams, right? And 2 hours minus 0 hours is 2 hours. So what's that equal? That equals 3 halves. What are we going to do with the grams and the hours? Well, the grams in the numerator, the hours in the denominator. I can write grams over hours. Now, if you were in MDE 61, don't answer because you know. You want to see what other people think now. Probably my fault. We didn't record a lot of that, but anyhow. Not sure where the last recording ended, but I think we'd already stated, what does this mean? What does this mean? 0, 1 means 1 gram of mold, the time is 0 hours. So everybody did quite well. 2, 4 means 4 grams of mold and the time is 2 hours. So the rise, which is 4 minus 1, means what? 4 what minus 1 what? Well, it's 4 grams of mold minus 1 gram of mold, which equals 3 grams of mold. So the rise of this graph has a clear interpretation if y is the mass of the mold and x is time. Okay, so this is the change in y, in other words, and this is the change in y. Okay, 2 minus 0, well, it's pretty obvious. That means 2 hours minus 0 hours, which is 2 hours. That's your change in x. Now we're anticipating change in y divided by change in x is change in that divided by change in this, which is the average rate of change of that with respect to this. In this case, that is mass of the mold and x is the time, okay, in grams and hours. So slope is rise over run, 4 minus 1 over 2 minus 0 is 3/2. What does that mean? That was a calculation we did. That's what you get if you use formula y2 minus y1 over x2 minus x1 for the slope. It means 4 grams minus 1 gram divided by 2 hours minus 0 hours. The change in the mass of the mold, which is 3 grams, divided by the change in the time, which is 2 hours. Okay. And you do the division, you get 3/2 grams over hours. What's that mean? Well, we got an immediate answer. 3/2 grams per hour. Okay. Now that might be where I stop, but it doesn't hurt to see it again quickly if you need it. Okay. So the change in y is the rise, the change in x is the run. That's a clear identification. So the slope is change in y divided by change in x. And that means, in terms of the definition of average rate of change of y with respect to x. And then that is the average rate of change of mold mass with respect to time. On that interval, on the interval 0, 2. Okay. Interval 0, 2 means 0 equals 0, 2 equals 2. And this whole thing kind of comes full circle, and we see how slope and the average rate of change just mesh. They're essentially the same thing if you have an interpretation. Okay. Okay, what's the average rate of change? What's the average rate of change of q of x equals x squared minus 2x on the interval from let's go on the interval from -1 to 1. Okay. Now you could draw a graph of this. You know how to draw the graph of x squared, then just lower it by whatever 2 to the x is, but I haven't showed you how to do that. And that always is kind of a point of confusion for people. So we're not going to draw the graph of that function at this point, okay? But there is a graph. Now on the graph, x equals -1. Y equals g of -1. Okay. Now, what's g of -1? Well, you plug x in. X has been replaced by -1, so replace x by -1. If you square -1, you get what? Show me with your fingers. Yes. And if x is -1, what's 2 to the x? 2 to the -1 is, yeah, 1 over 2. Okay. So g of 1, g of negative 1 is this. And on a graph, x equals 1, y equals g of 1, which is what? 1 minus 2, isn't it? Because 1 squared is 1, 2 to the 1 is 2. Okay. So we can, without trying to sketch a graph of this function, we can sketch the point negative 1, 1/2. I keep drawing these y equals negative 1/2 and x equals negative 1 lines. And I seldom see people actually draw those lines. It just takes a second to draw one of those lines. And think about what it means. The point negative 1, 1/2 is where the y equals 1/2 line meets the x equals negative 1. This is helpful in calculating the slope just visually, okay? So here now we have the x equals 1 line. And if x equals 1, y is negative 1. Well, if y is 1/2 here, negative 1, y equals negative 1 is probably about down here. If this is 1 unit of distance here, this is half a unit, so this ought to be twice as far as this. You should be sketching graphs and reminding yourself of these things and thinking about the estimates, because it gives you a better picture to hang everything else on. There's going to be hanging a lot of algebra on some of this stuff. And if you don't have a picture to hang the algebra on, it's a lot more confusing for most people. Some people, different brains are wired different ways. And anyhow, there it is. So here's the point. 1, negative 1. And now we have a picture. Here's a run and here's a ride. Now I'm not going to write out all the details, but you ought to write them out. What's the run between here and here? Can you show me with your fingers? Well, the run goes from this point, from this vertical line to this vertical line, right? It goes from the x equals negative 1 to the x equals 1 line. The run is 2. So it's clear just from looking at the picture. Of course, if you had weird numbers here, you'd have to say, okay, well, 1 minus negative 1. Okay. And actually, I guess I'll do that. 1, at least write it out. Negative 1 equals 2. That's the run. What's the rise? Well, the rise goes from y equals 1/2 to y equals negative 1. Rise is negative 1 minus 1/2, which is negative 3/2. Okay. You subtract where you start from where you end. We talked about why that is previously. Make sure you understand it. We can't take the time for me to go through the explanation again, except very briefly. If you go from milepost 10 to milepost 17, you go plus 7 miles. And that's what you get if you subtract where you start from where you end. If you go from 17 to 10, you go minus 7 miles. Subtract where you start 17 from where you end 10, and you get negative 7. Okay. So there it is. And the slope is then -3/4. We get that by dividing this by 2. You divide -3/2 by 2, you get -3/4. So make sure you can do that arithmetic. Okay. There's a picture. So as soon as we have a function and an interval, we figure out the point corresponding to this number and the point corresponding to this number. The point corresponding to x equals -1 and the point corresponding to x equals 1. Okay. We do that by plugging -1 into the function and getting the value. etc. Okay. Now, I think about the third problem, or the fourth problem on the task, on the homework, asks you to do that for some function on some interval. And different people are going to get different functions at different intervals. Okay. But I think it's also a video. So if you understand even halfway what I just did here, you're going to understand the video. If you understand it well, you probably don't even need the video and you save yourself some time. Fair enough? Okay. So that makes, and that is problem 3. That makes problem 3 pretty accessible. And problem 4 is the same thing, except, well, you have to look at the video. Problem 4 doesn't give you numbers for both points. It'd be like the interval from -1 to C, just the letter C, okay? And then you'd have to use C. G of C would be C squared minus 2 to the C. And then you just write out everything just the way you'd write it out if you had numbers. But if you don't have a number for this coordinate, you're going to have C in it. That's a very transition. It should be an easy transition for you, especially since there's a video. Okay. So given time constraints and some of the other stuff, I need to explain it in a little more detail than I wish. And that no insult in that. That's it. The next problem, you got X and X plus H. Okay. And I think there's a video with that one. Let's make sure. Yeah, I would have put a video with that because when I design these problems, if it's the first time you've seen something that isn't an obvious extension of something else that you've already seen, I tend to make sure there's a video with it. Okay. Sometimes I screw it up. Okay. Is this exponential function increasing or decreasing? This way for increasing, this way for decreasing. Everybody vote. Increasing or decreasing? This exponential function. It's increasing. The y value, you go from left to right, as x increases, y increases, right? So you just look from left to right, it's increasing. If I had a function that was shaped like this, would that be increasing or decreasing? It'd be decreasing. Okay. Let's get over to the video. So okay. We can say this is concave up or concave down. I'm going to say concave up. I'm going to say concave down. How many never really thought about what concave means? Okay. Concave up means it opens up. It means if you're in this cave, you're looking upwards. If you're looking out, okay? If this is the shape of the cave and you're sitting here and you're looking out, hopefully there's a seat there, it's a little bit steep, okay? And you're looking out, then you're basically looking upward. If you're in this cave, I guess you could be sitting there, but let's say you're rock climbing or something. If you look out of the cave, you're looking down. You might be looking to the left or to the right, but you are looking down. Okay, that's what concave up and concave down mean. Okay, so this is increasing and concave up. This is decreasing and concave down. Okay, what's this? Increasing or decreasing? Everybody vote. Increasing or decreasing? It's increasing. Y values are getting bigger and bigger. Is it concave up or concave down? Yeah, if you're looking out from here, you're looking down. Okay. You're looking down and to the right, but you're looking down. And it's the down part that counts. It's concave. So this is increasing. Okay. And you can think about what decreasing and concave up would look like. if you click this function about the y-axis, it's now decreasing, but it's still concave. And you can think about that, but the text gives you an explanation. So that's my brief explanation. Hopefully you understand it from what I've just said. And on that one, there is no video because I would have assumed that you could figure it out from the text. But really, I should have mentioned it in class before I made this assignment. Okay. So right there's a function. We don't even put y values on it to answer this question, although we could. Okay. If I was to ask you to shade the part of this function that's increasing, okay, or the parts of this function that are increasing, okay. Just raise your hand, point at me, make some kind of a gesture when I get to the point where the function starts to increase, right? Some of you are a little late, it was here, but I think you see that, okay? You're unsure of yourself, that, you know, prime yourself. The function starts to increase. There. Okay. Now tell me when it stops increasing. Ready? If you got it in your head, can you visualize the point where it stops increasing? Okay, so I'm going to move here and you tell me where to stop and what to hit. Okay, that looks good. It'll be about here. Stops increasing here. So the function is increasing from here to here. And also here to here. And the function apparently ends here. Okay. Well, the interval from here to here, if that's 8, then 4 would be about here. And 2 would be about here. Let's see, 4 would be about here, 2 would be about here. 6 would be about here, there's 8. So looks like it's increasing. And of course, this is negative 4, not 4. Increasing on about negative 4.5. 0.5. I am saying that x is about negative 4.5 here. X is about 0.5 here. You might have a different answer. I think it's a little less than 25 on the scale, but you understand what I'm saying? Now, you see it in open math, you're going to have scales already there, and you're going to have a whole grid, and you don't even have to think very hard, okay? Because it's probably going to be pretty obvious integers. So, and then on x equals 5.3 to x equals 7.2. And then I'll bet you can give me one interval where it's decreasing. Yeah, it's decreasing from here to here. Okay. Where does this function reach a relative maximum? By a relative maximum, I mean a point where if you move to the right, it decreases. If you move to the left, it decreases. Okay? Like the top of the hill. If you're at the top of the hill, if you move that way, you're going to go downhill. If you move that way, you're going to go downhill. Okay? So where does that occur? At x equals what? Not the way I've got it marked. It's not x equals 0, but it's pretty close. Okay? The way I've got it written, it's on the line x equals 4. It's here. Okay? This is a relative max. And I'll bet you can tell me where there's a relative relative minimum. It's like you're at the bottom of the valley. Okay? And that's around x equals 5, 5.3, right? Relative max is about x approximately equal to 0.5. Okay. Now, another thing I'd have to say is if you're not reading the text, you need to be reading the text. You can get a lot of this stuff without reading the text, but I can't say everything in class. Have you ever heard of the Dopeler effect? It sounds kind of like the Doppler effect. If the train's coming toward you, the whistle sounds higher. It's moving away from you, the whistle sounds lower. It's kind of choo 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 choo. Right? That's how they sound, isn't it? When I was a kid, that's the way they used to sound because they were steam engines. My parents tell me if I was in a car and a train went by, I'd stand up in the front seat. There were no seatbelts in those days. We had to live dangerously. Okay. I'd stand up in the front seat, choo, 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 and spray all over the front windshield. They'd have to clean the windshield every time a train went by. Okay. Okay. Well, the point is, if you haven't heard that, go sit in the railroad tracks as a train comes by. No, not on the tracks. You know, safely back from the tracks, you'll still hear the effect. Okay, don't sit on the tracks. Please, nobody sit on the tracks and blame me for it. Okay, I assume everybody in here has some common sense and sense of self-preservation, right? Okay. Now, so the Doppler effect, the Doppler effect is that. I could explain the physics of it, that you don't want to hear. The Doppler effect is the phenomenon whereby stupid ideas seem smarter the faster they come at you. Stupid ideas seem smarter the faster they come at you. Now, if I was to tell you every stupid idea that's in the book and in my brain regarding this stuff, it would come at you so fast, it would seem smart, but you wouldn't absorb it. Okay, so we got to pace it so you can absorb it. If you find I'm going too slow, let me know. If you find I'm going too fast, I'm going as slow as I possibly can. Okay. Now that's related to something. So that's relative maximum and relative minimum. And my point is, read the book. You get more detail that I can give you. You get more explanation. Also, there are videos that go along with the book on your web page. Use them. If the videos and the assignments are sufficient, that's fine. Okay. But remember, don't just imitate the videos when you do the assignments. Make sure you understand the video so you can come in here and do the same thing if I ask you a different question on quiz. Okay. And that is how you get prepared for a test. Okay, now quickly. You've got tables, but there's plenty of explanation with that. Concave up, concave down on intervals, one local maximum. Okay, now question 11 actually assumes that you've got a graph, which assumes you've got a graphing calculator, which assumes you know how to use the graphing calculator to make the graph of that function. Okay, we'll learn how to make the graphs of polynomial functions, but they only work if you can figure out where the zeros and stuff are. Okay. They're important. You get a lot of them in calculus. So if you got a graphing calculator, use it to answer that question. If you don't, just answer by saying, I don't want to use my graphing calculator because I respect that. And I'll give you credit for the problem. Because this gives you a picture like that and asking these questions. Okay. If you don't have a graphing calculator, if you've been able to answer it when you've been given the graph, then anybody can draw it in their graphing calculator and answer it. So I'm not too concerned about that. So an average rate of change, mark the points you need, and a couple of other kind of leading questions. If you understand everything else, you should be able to answer. And if you can't, it won't hurt your grade that badly, but try to answer. Okay. Okay, now there's a lot more that I would kind of like to say, but you know, we kind of have just seconds left. Let me take just another quick look at you got the assignment on inverse functions. Remember that we start the inverse function by switching x and y. I'm going to do one real quickly. Okay. Now, remember that we did this by switching values in the table. We did this last week. You might want to review that because that's the fundamental idea. If we have a function like y equals 3x plus 5, and if it's f of x equals 3x plus 5, well, y equals f of x. So y equals 3x plus 5. Okay. Now, what did we do to construct the graph of the inverse of the squaring function? We switched the numbers in the x column and the y column, and we got a graph that looks like a square function laid on the side. Again, you should be reviewing these, at least looking at the pictures to remind yourself of what you see once the assignments are posted, okay? Yet I can't guarantee that this assignment will get posted tonight just because of my priority is to answer questions if I get emails. If I don't get any emails, I'll probably get this posted, okay? If I do get emails, it might not be posted tomorrow, and that sometimes happens between Thursday and Friday. Okay. Okay, y equals 3x plus 5. Okay. Switch x and y. You get x equals 3y plus 5. Solve for y. Now this should be easy to solve for y. You got x equals 3y plus 5. You're trying to solve for y. So maybe let's go ahead and write 3y plus 5 equals x, just to get the y on the left, which is where we usually want to isolate our variable. We subtract 5 from both sides. Then we get 3y equals x minus 5. Right? Now this is very simple. This is very simple algebra of solving linear functions. And if you don't remember it, it should come back to you. And if it doesn't, please let me know. There's an algebra review link somewhere on your assignments page, so you might want to look at that. But then we get 3y over 3 equals x minus 5 over 3, so that y equals x over 3 minus 5 over 3. And here's your inverse function. So found that if f of x equals 3x plus 5, the inverse function, which we denote as f inverse of x, it's like f to the minus 1, but it's not, that doesn't mean 1 over f, it means inverse function, equals x over 3 minus 5/3. Real quickly. We're doing a little function notation that you will want to be able to use. We've done enough function notation. We should be able to do this. F of x is 3x plus 5. So f of f inverse of x, we're replacing x by f inverse of x. If we replace this x by x inverse of x, we get 3 f inverse of x plus 5, which equals 3 times x over 3 minus 5/3 plus 5. Again, replacing f inverse of x now by the formula for f inverse of x. And if you understand the function notation that we've been over, that should be something you can sort out. It might be a little bit challenging for you. We'll see how you do. If we multiply all this by 3, we get x minus 5. And then we have plus 5. That equals x. If we did the inverse function correctly, we have to end up with x. Okay? The book will give you more explanation of that in additional examples. It gets a little more complicated if f of x was like 3x plus 5 over 2x minus 7. The algebra would get kind of challenging. Okay? I'd be happy if you could do that algebra. We'll have to talk about that next time. I don't think you'll see much of that. It's mostly pretty simple functions. Switch x and y, solve for y, and you got your function. Plug it in to the original function, you should get x. Talk about stupid ideas coming at you fast. That was pretty quick.